Hi guys, today we're going to look at day 5 notes with symmetry and even versus odd functions. So we're going to say that a function is even if f of negative x equals f of x for every value of x in the domain of f of x. That sounds a little confusing, but let's just take a look at what's happening in this first example. So here we have f of x equals x squared is graphed below. Evaluate f of 3 and f of negative 3. So if I go over to where x is positive 3, we are up at the value of 9. So f of 3 equals 9. Then if we look at f of negative 3, again x value, going to the left 1, 2, 3, up to the graph 1, 2, 3, 4, 5, 6, 7, 8, 9. That's weird. Except not really. If I plug in a value, say x, and then I also plug in its opposite, the negated version of it, negative 3, we should get the same exact value. This means that it's even. So the symmetry here would be the y-axis. If I were to reflect over the y-axis, I would have the same exact graph. So here we're going to say reflection over the y-axis. So we're going to say symmetric about y-axis. So if it's even, it's symmetric about the y-axis. That's the main thing you need to understand right now. Then we have something called odd functions. An odd function, or a function is odd if f of negative x equals negative f of x for every value of x in the domain of f of x. So we have this function here, f equals x to the third, and it says to evaluate f of 2 and f of negative 2. So I'm going to ask that you do that right now on your own. Notice that the scale is going up by 4, so we have 4, 8, 12, 16. Same thing in the negative direction. So f of 2 is 8. F of negative 2 is negative 8. So you can see that this qualifies as the function being odd because if I plug in an x value and I get a y value, when I negate the x value, I should also be negating the y value. And this symmetry for odd functions is a reflection through the point called the origin. And the origin is 0, 0. So what I'm going to tell you is that if I were to reflect through the origin, it's the same as a rotation of 180 degrees. Now I'm just going to ask that you visualize this. You can try to do it on your own paper, just turning your paper 180 degrees. So take a look at where your graph is right now. It's going in like a, I'm not sure how to describe it best, a backwards kind of S shape. I don't know how to describe it, but take a look at it, get that picture in your brain, and then turn your paper 180 degrees. When you do that, you see that you still have that same exact sideways backwards S shape. Okay, now turn your paper back to double check to be sure. Oh my goodness, we're right. So what we're saying is that if we either rotate 180 or we reflect through the origin, it's an odd function because it's symmetric about the origin. So to recap, evens are symmetric about the y-axis, odds are symmetric about the origin. So we're going to flip to the next page and get a little bit of practice looking at graphs. So looking at these three graphs, we have graph A, B, and C, and we are asked to determine if it's odd, even, or neither, and to explain our response. So the first thing you need to do is look for some symmetry. And in this first graph, this is actually what we just saw, where we could rotate or reflect through the origin. So we're going to say this is odd. And this is because it's symmetric about the origin. Okay. Then when we look at the next graph, if I were to draw a line of symmetry or plot a point of symmetry, my line would be going through here. So if I were to fold this parabola in half, it would be folded along this dotted blue line that I drew. That dotted blue line is not the origin, nor is it the y-axis. So in this case, we have a neither, because it's not symmetric about the origin nor the y-axis. Then if we look at the last graph, if you were to fold this parabola in half, where would you draw your line of symmetry? If you said on the y-axis, you are correct, which means that if we are symmetric with respect to the y-axis, then this function is even. And again, this is because it's symmetric about the y-axis. So I want you to use these three graphs to kind of help guide you when you do these practice problems below. You do need to explain your response just as I did up top with you guys together. Now you're trying it on your own. I'm going to write my answers quietly, silently, so that you can do this, and then just check back in with me as you finish each problem. If you need more time, just pause the video, look at my explanations, and then maybe if you got something wrong, think about what we did up top. If you're ready, just move on with me to the next page. So the second part of today's lesson is to talk about or describe symmetries. The functions below are not odd or even, meaning that they were probably described as neither at one point in their lifetime. So we're asked to describe any other types of symmetries that we can find. So sometimes we can rotate around a point other than the origin, or reflect through a point other than the origin. We may also be able to flip a graph or fold a graph on some line other than the y-axis, meaning that it's symmetric either about a point or about a different line. So if we look at this first one, if I were to rotate this picture 180 degrees, this graph looks exactly the same after a rotation around a point, but not the origin. That point happens to be right here. So this one has point symmetry at 0, 2. Because if I rotate that graph around that point that's there in red, it's symmetric after a rotation of 180, or a reflection through that point. The next one, if you try to draw any lines of symmetry, either vertically or horizontally, you're not going to get any, nor will you get tic-tac-toe. But if you were to rotate around a single point, try to figure out what point you could rotate around. Look at that graph closely. Find a point that might be symmetric for this graph. So I found this point right here at 2, 1. If you think about rotating that graph around that point 2, 1, you would see that it lands exactly in the same position as it should, or as it was originally. So those first two had point symmetry. Now the next ones, if I try to rotate around a point that might be important to us, like maybe this vertex point, you can see that if you rotate it, it would end up looking something like this, right? So that's not what, that's not what we're talking about here. Let me try to undo that. So maybe there's a line of symmetry. Typically we've talked about the y-axis, but that's not going to work here for this one. If I want to fold this parabola in half, figure out where that line would go. And it looks like it's right here. This is an x equals equation because we are over on the x-axis at -3. And any value on this line, any coordinate point, starts with a -3 comma something, right? -3, -6, -3, +4, whatever it happens to be, which means it's an x equals equation. X equals -3 would be the line of symmetry. Okay, try to find your line of symmetry on the next one. This time, we're crossing the y-axis, so this is y equals a value. We're up 1, so y equals +1. If you have any questions, try to talk to the teacher that's near you. Otherwise, pause, rewind, go back, and revisit. Otherwise, you're going to move on to your homework. You are doing all problems on your homework, so I'm not going to sit here and circle problems with you because you should be able to be successful in all of them. So go ahead and move forward onto your homework. If you need to try the classwork first, that's fine for more practice. And then remember, you do have a ticket out to try. Happy odd, even, and neither function day.